Okay, good day everyone. Welcome to the second part of the discussion on annuity. This time we will have future value and present value of simple annuity. And this is the objective. And at the end of the discussion, you should be able to answer this question and apply it in finding or computing the future value and present value of simple annuities. Before we move on with the computation, let us define first the future value of an annuity. So it is the total accumulation of payments and interest earned, or it is the sum of all payments of an annuity at the end of the last interest conversion period. While the present value of an annuity, it is the principal amount that must be invested today to provide the regular payments or to have the future value. Okay, you have learned in the first discussion that there are three types of simple annuity. We have the ordinary annuity, annuity due, and deferred annuity. So for the first one, we'll have the future value and present value of simple ordinary annuity. Okay, let's have the future value of ordinary annuity. So the future value F of an annuity is the total accumulation of payments and interest earned. So the formula for this ordinary annuity future value will be F times FB, future value, is equal to R times the quantity of 1 plus I raised to the n minus 1 divided by I. So where FB is your future value or amount, your R here is the regular or periodic payment, I is the interest rate per period, and N is the total number of payments. But before we can substitute the value of I, we have to find it first by the formula R divided by M, where R is your rate of interest or the interest conversion period, and M is your conversion period. Okay, so you are asked to find or to use the 6 decimal places for the value of I. Also, we need to find the value of N. And this is equal to T times M, where T is the total number of years and M again is your conversion period. So this is the formula for the future value of ordinary annuity. Okay, the future value F of an annuity is the total accumulation of payments and interest earned. So the formula will be FB, or the future value, is equal to R times the quantity of 1 plus I raised to the power of n minus 1 divided by I, where FB is the future value or amount, R is the regular or periodic payment, and I is the interest rate per period, and N is the total number of payments. To get the value of I, we need to compute it first by R divided by M, where R is the rate of interest or the interest conversion period, M is the conversion period. And you're going to use, to find the value of N, you will have T times M. So T times M, where M again is your conversion period and T is the number of years. Okay, let's have an example. If you pay 50 pesos at the end of each month for 40 years on an account that pays interest of 10% compounded monthly, how much money do you have after 40 years? So we have here the payment interval each month, 50 pesos, and the conversion period is compounded monthly. So they are the same, so this is an example of simple annuity. And then you are paying at the end, so this is an ordinary annuity. So this is a simple ordinary annuity. Okay, so the given values are, so you have here your regular periodic payment is 50 pesos, your R. Your T here is you're going to pay for 40 years. Your R is 10% or change to decimal. move it 2 places to the left or divide it by 100. So you will have 0.10. And then your M is monthly, so that will be 12. And you are asked to find the future value. So first, let us solve for the I. So again, the formula for I is R divided by M. So you will have 0.10 divided by 12. So use 6 digit of your of the value. So you will have 0.008333. So repeating yung 3 but use 6 digit. You may use ordinary calculator or scientific, but it is preferred or much better if you can have your scientific calculator. And then let's have the value of n. So this is only equal to t times m. Your time is 40 years times m is 12, so that will give you 480. So to find the future value, we will be using this formula. So we'll just substitute all the given values. So you will have periodic payment is 50. 1 plus I, so you have his 0.00833 plus 1. So you will have 1.00833. And then you have raised to the n, that is 480 minus 1. And again, the value of I is this 1. So we will be solving first for this one. Enter this on your calculator. 1.008333 raised to the 480. So you will be needing a scientific calculator. And then after getting that one, you subtract it by, so the value will be this one. So 6 digit. Here, we write all the values for the answer to this one. And then, next one is subtract 1. So you will have 52 and times and write the remaining values. And then next we divide it by the I. So we divide this one. So you will have now 50 times 6,323.310063. So write again everything and then multiply this. So the future value will be 316,165 and 50 pesos. So that will be your final answer. You may write your conclusion in words. Okay? So I hope that is clear. Okay, let's have another example. Jenica's father saved 3,000 pesos at the end of every 6 months in an education plan that earns 5% per year compounded semi-annually. What is the amount at the end of 18 years? So again here, the conversion period is compounded semi-annually and you are paying every 6 months. So every 6 months and semi-annually are the same. So the payment interval and the conversion period coincide. So this is an example of simple annuity. And again, you are paying at the end of every 6 months. So again, this is an simple ordinary annuity. So the given here is your periodic payment is 3,000 and then R is 5%. You have your conversion period which is semi-annually. So you will have here 2 or twice a year. And then you are asked to find the amount after 18 years. So the time is 18 years. And then you are asked to find the value of the future value. And then again, let's solve first for the value of I. You will have 0.05 divided by 2. That will give you an exact value of 0.025. And then to solve for n, we have t times m. Your time is 18 years times 2, so that will give us 36. Again, subtract everything, substitute everything to this formula. So you will have periodic payment is 3,000, 1 plus I is 1.0125, your n is 36 minus 1 divided by the value of I again. So you may just enter this using your scientific calculator and you will get the product. The answer for this part, 1.025 raised to 35 and then subtract 1 divided by 0.025 is this one. And then multiply this 57 point something everything by 3,000. So the future value will be 171,904.24. So this will be the amount of the educational plan after 18 years. Okay, let's have now the present value of ordinary annuity. So the present value P of an annuity is the principal amount that must be invested today to provide the regular payment. So this will be your formula. Again, PB is your present value or amount, R is your regular or periodic payment, I is the interest rate per period, and then N is the total number of payments, I is still R divided by M, and N is T times M. So if you will notice, N here becomes negative, and instead of subtracting 1 here, you will have 1 minus. So ito ang mina-minus natin. So that is the difference between present value and future value. So nandito yung 1 minus every here, and then you have here the negative N. So this is the formula for the present value. Okay, let's have this example. Jacob borrows money to buy a motorcycle. He will repay the loan by making monthly payments of 1,500 for the next 24 months at an interest rate of 9% per year compounded monthly. How much did Jacob borrow? So here again, the conversion period compounded monthly, and the payment interval, so making payments monthly, are the same. So this is simple annuity, and you are paying it at the end of each month. So this is ordinary annuity. So for the given, so this is simple ordinary annuity. So for the given, you have the periodic payment 1,500. For the time you have here 24 months or equivalent to 2 years, the rate is 9% and compounded monthly, so you will have the value of M is 12. And then you're asked to find the present value. So solving for I, again that is R divided by M, so 0.9%, 0.09 divided by 12, so that will give us an exact value of 0.075. And for N, let's multiply the time, which is 2 years times the conversion period 12, so you will have 24. And then substitute to the formula of present value, so we will have this one. So again, R is 1.5, this is 1 plus I, so this will give us 1.0075, and your N is 24, so you will have negative 24 divided by I, this one. And then again, we work on this one. So 1.0075 raised to the negative 24 of your calculator. So this will be the value. And then we subtract it by 1. Or we subtract it from 1 rather. From 1. And this will be the value. And then divide it. So you will have 21 point this one. Multiply by 1,500. So the future value, or the present value rather, is 32,833.72. So this is the amount that Jacob borrowed to buy a motorcycle. So again, you may write your conclusion in words. Okay, another example. JM works hard because he wants to have enough money in his retirement account when he reaches the age of 60. He wants to withdraw 36,000 every 3 months for 20 years. For 20 years starting 3 months after he retires. How much must Jacob deposit at retirement at 12% per year compounded quarterly for the annuity? So again, the payment interval is 36,000 every 3 months, and the conversion period is compounded quarterly. Okay, so they are the same, and he will pay it starting 3 months after niyang mag-retire, or he will receive it. So you will have here ordinary simple annuity, and the given are periodic payment of 36,000 for 20 years. He will withdraw it for 20 years. The rate of interest is 12% or 0.12, and compounded quarterly is 4. So you have here the present value, magkano yung dapat niyang ihulog or yung perang kailangan niya ngayon pa lang to have that amount, or to receive 36,000 pesos after retirement every 3 months. So solving for I, you have 0.12 divided by 4, again, exact value of 0.03. And for n, you have time is 20 years times 4, so you will have 80. Substitute to the formula for present value. So you will have 36,000 times 1 minus your I is 0.3 plus 1. So you will have 1.03 raised to the negative 80 divided by 0.03. And then again 1.03 raised to the negative 80. And then we subtract it to 1 or from 1. And then we divide it by 0.03. This will be the answer. And then we multiply it by 36,000. So he needs 1,087,227.48 for the payment. Okay, so that will be the present value. Okay, I hope the difference between finding the present value and future value is clear. Okay, so this time let's have the future value and present value of simple annuity due. We define simple annuity due as annuity wherein payments are made at the beginning of each interest conversion period. So for the formula for the future value of annuity due, we will be using this one. So almost the same process. Okay, but this time you have an additional value to be multiplied, which is 1 plus I. Okay, let's have an example. Suppose Mr. Bruno deposited 30,000 pesos at the beginning of each year for 3 years in an investment that earns 8% per year compounded annually. Okay, annually, what is the amount or future value of the annuity? So here we have here the word payment at the beginning. So therefore, this is an example of annuity due. So simple annuity due. So the given here is 30,000 for your periodic payment. The time is 3 years. Rate is 8%. And compounded monthly. Compounded annually. So we will have M is 1. And we are asked to find the future value. So again, solve for I. So that will be 0.08 divided by 1 is still 0.08. And your n is 3 times 1 is still 3. So we use this formula. So your R is 30,000. We will have here 1 plus I. That will be 1.08. Ito siya. And then here is also 1.08. The value of n is 3. Here, the exponent 3. And your I is 0.08. So we simplify this one first. So 1.08 raised to 3 minus 1, that will give us this value. Dividing it by 8, 0.08 by the value of I, and this will be the value, 3.2464. So we multiply 1.08 times the value of this, 3.2464 times 30,000. So the present value of the annuity due, the future value of the annuity due is 316,165 pesos and 50 centavos. So this is the computation for annuity due. Okay, this time let's have the present value of annuity due. So the present value P of an annuity due is given by this formula. Okay, so again, this part will only become 1 minus the quantity 1 plus I raised to the negative n. Okay, so still the same process. Okay, let's have an example. Miss Sai borrows money for the renovation of her house by making payments of 25,000 every 6 months. At the beginning of each quarter, for 15 years at 8.5% compounded semi-annually, how much did Miss Sai borrow? So here again we have at the beginning, and then semi-annually, and every 6 months. So the interval payment and the conversion period is the same. So simple to, and then you have the payment at the beginning. So this one is a simple annuity due. So for the given, you have 25,000 pesos. Time is your pay. She's going to pay it for 15 years at 8.5% or 0.85, and then you have here semi-annually, your M is 2. So how much does Miss Sai need for the renovation? So we will have for the I, 0.085 divided by 2. So you will have 0.0425. And for the N, that will be T, 15 years times 2. So we'll have 30 years. This will be your formula. Substitute here. You will have 25,000 times 1 minus 1 plus I again is 1.0425 here and here. Then divide by the value of I. So working on this, you will have 1.0425 to the negative 30, and then subtract it from 1. So you will have this value. And then we divide it by the value of I, 0.0425. So this will be equal to 16.77901770. Okay, you have to write everything here. Multiply by 25,000 and the value of 1 plus I. So this will give us the value for 437,303.13. So this is the amount that Miss Sai needs for the renovation of his house. So almost half a million. Okay, so let's move on now to the last type of simple annuity, which is the deferred annuity. It is defined as an annuity in which the payment is not made at the beginning nor at the end, but on a later date. So we will find the future value and present value of deferred annuity. Okay, to define the word defer, it means to put off or to delay or to postpone. That's why when you are deferring means you are delaying it. Okay, so when you are deferring your payment, it means you are delaying the payment, but you are not violating any rules. Okay, that's why when we say deferred annuity, okay, it is neither paid, the payments are not made either at the beginning or at the end, but on a later date or on a delayed date. So for deferred annuity, we have the term period of deferment. So period of deferment is defined as the length of time when payments are made. So the first payment is made one period after the period of deferment. Example, an annuity that is deferred for 6 periods will have the first payment at the end of the 7th period. Or an annuity whose first payment is made at the end of 11 periods, meaning the period of deferment is 10 periods. So, parang nag-add ka ng 1. Okay, for the future value of deferred annuity, it is only the same as the future value of the simple ordinary annuity. So, you can only distinguish one from the other if you see the word deferred. Okay, so but the formula for the future value is the same as the formula for the computation for the simple ordinary annuity. Okay, so this one is the formula for the present value of deferred annuity. So medyo mahaba lang, but and additionally we have here the letter D. So how do we find the value of D? D refers to the total number of deferred period, and to find that you have to multiply the number of the deferred years times the conversion period. So, i-multiply pa natin siya sa M before we can substitute it here. Okay. Okay, let's have this example. Find the present value of a deferred annuity of 2,000 every 3 months for 6 years, that is deferred 3 years if money is worth 5 compounded quarterly. So again, you have here compounded quarterly, the conversion period. The payment interval is every 3 months, so they are the same. And then you have the word deferred annuity. So for the given, we have 2,000 pesos for your periodic payment. So you're going to have it for 6 years at a rate of 5% and compounded quarterly is 4. And the deferred year is 3 years. So I use capital D here and you're asked to find the present value. So to solve for I again, that is only 0.05 divided by 4. So you will have 0.0125. And to solve for N, that is T times M. So you have 6 years times 4, so you will have 24. And to solve for D, so we'll simply multiply D by M. So that is D times M. So the deferred years is 3, so times M is 4, so you will have 12. Okay, let us continue using the values that we have solved earlier. So we will have it here. So this will be the formula. All we have to do is to substitute. So we'll have R is 2,000 times 1 minus 1 plus I is 1.0125. And you will have here N plus D. That will be 12 plus 24. And you have here the negative sign. Divided by I, which is this one. Minus 1 minus again the value of 1 plus I divided by the value of I, and then here you have to raise it to the negative t, so you will have negative 12. So work on it one by one. We will have 1.0125 plus this one in your calculator, and then you have raised to the negative 36. Okay, and then subtract the answer from 1, and then you divide it by 0.0125. So this will give you this value. And then for this one, you have 1.0125 raised to the negative 12. Whatever is the answer, you subtract it from 1. And then you divide it by 0.0125. So this will be the answer. And subtracting this one, 28 point something minus 11 point something, that will give you 17.76, 79, 55, 41. And then lastly, multiply it by 2,000. So the deferred amount will be 35,535 and 91 centavos. So this is how you solve the present value of a deferred annuity. Okay, that ends our discussion for today. Again, visit your Google Classroom for your output, and then kindly subscribe, like, comment, and share. Thank you.